In this video, we are solving a problem basing on calorimetry. The problem is like this. 1 gram of ice is at minus 10 degrees centigrade. How much heat is required to convert into steam? First thing is, ice cannot directly convert into steam. Lot of things are involved in the journey. You will see what are they are involved, right? So what is available for you is first of all 1 gram of ice. That is at what temperature? Minus 10 degrees centigrade. If ice has to convert into steam, first of all it has to convert into water. Ice to water happens at 0 degrees centigrade, but ice is at minus 10. So the first thing that has to happen is this has to first of all come as 1 gram of ice at 0 degrees centigrade. So if the temperature has to rise from minus 10 to 0 degrees centigrade, we need to supply certain amount of the heat, right? So what we have to say in step 1, heat required to rise temperature of 1 gram of ice from minus 10 degrees centigrade to 0 degrees centigrade is, as there is a rise of temperature, we shall take the definition of specific heat as amount of heat required to rise the temperature of unit mass of substance by 1 degree centigrade. From that I can write dq equal to ms delta T. So dq is, or else I will call it as dq1 as ms delta T. M is the mass of the ice, that is 1 gram. I will take in the existing system itself, CJ system itself. Specific heat of ice is 0.5 calorie per gram. You need to know that specific heat of ice is 0.5 calorie per gram per Kelvin. Delta T is minus 10 to 0 is 10 degrees centigrade. So this is 0.5 into 10, that is 5 calories. Because you have taken this in calories, you will get this answer also in calories. Now it has reached 0 degrees centigrade. So first of all, what has to happen is at this 0 degrees centigrade, ice has to convert into water. So 1 gram of water at 0 degrees centigrade has to happen in the second step. This is the second step. So how much heat is required in this case? Let's find out. What we have to find out is heat required to convert 1 gram of ice. Be careful, earlier that is at minus 10 degrees centigrade, but now it has already reached 0 degrees centigrade. This can be done basing on the definition of latent heat, which says that latent heat is the amount of the heat required to convert unit mass of substance from one state to other at constant temperature. Now this is going to happen at constant melting point temperature 0 degrees centigrade. From this I can write dq equal to ml. That implies heat required in this case dq2 equal to ml. Mass of ice is 1 gram. Latent heat of ice is 80 calorie per gram. So gram and gram will cancel, that becomes 80 calories. Here you need to remember one more point. Earlier, one point that we need to remember is specific heat of ice. Similarly, now the another point that we need to remember back is, where latent heat of ice, you need to know these factors. Many times they may not give it in the exam as a data. 80 calorie per gram. You need to remember this data also. Now this is converted into water. It is no more ice. It is converted into water. Now this water, if it has to, so ice has been now converted into water. Here also it is ice at 0, but now it is converted into water. From water, if it has to convert into steam, first of all, its temperature has to rise by 100 degrees centigrade, because conversion happens at 100 degrees centigrade. So what this has to become now? 1 gram of water Yet not 0 degrees centigrade, but at 100 degrees centigrade. So here also it is still water, but its temperature is going to rise from 0 degree centigrade to 100 degrees centigrade. So how much heat is required for that? Let's try to find out. So what I have to find out is now heat required to rise 1 gram of water. It is no more in ice format. It has already converted into water. To rise temperature from where to where? 0 degrees centigrade to 100 degrees centigrade is, as there is a rise of temperature involved, we can take the definition of specific heat. From that I can write dq3 equal to ms delta T. Mass of the water is 1 because all that ice is converted into water. Specific heat of water is 1 calorie per gram per Kelvin. Earlier I have written specific heat of ice, but here we need to know specific heat of water as 1 calorie per gram per. Be careful. Specific heat of ice is 0.5 calorie per gram per Kelvin, whereas specific heat of water is 1 calorie per gram per Kelvin. You need to remember these things. Huh? So if you simplify this, how much it will be? 100 calories. So now it has reached 100 degrees centigrade. What's the next step that it has to happen is? The fourth step. 1 gram of water has to convert into steam. That's the question. This happens at 100 degrees centigrade because there is a change of state. As there is a change of state, latent heat definition has to be taken into account and the respective dq. So what is that? Let me write that forth. Heat required to convert 1 gram of water into steam at 100 degrees centigrade is, I can call that as dq4. Change of the state is involved, therefore ml. Mass is 1 gram. Latent heat of water to steam is 540 calorie per gram. So here is one more fact that we need to remember. What is that one more fact is? Latent heat of steam, that is water to steam, is 540 calorie per gram. So you need to know all these factors. Not only for this problem, this data is used in many of the problems. Therefore, these four things that whatever I have highlighted with yellow has to be remembered. Be careful about it, right? Okay. Assuming that you know these things, this is 540 calories. So at different steps, we need different energies. So what is the total heat energy required to do all this? What we can write? That implies total heat energy required to convert 1 gram of ice at minus 10 degrees centigrade to steam. Of course, obviously at 100 degrees centigrade is, how much is that? The Q1 of the first case, second case, third case, and fourth case. All of them has to be added. So the first case is 5 calories, second case is 80 calories, third case is 100 calories, and the fourth case is 540 calories. So 5 and 80, 85, 85 and 100 is 185. 185 and 540. If you try to add both of them, it becomes 725. Be careful, you will get the answer in Kelvin because you have taken all this data in, answer in calories because you have taken all these data in calories itself. Suppose you want the answer in joules, you can say that 725 into 1 calorie is 4.2 joule. It becomes approximately 3045 joule. Anything is okay. You can use any of these answers depending on what's your question. Options are available for you. So in solving these problems, we have got so many things into our picture that whenever there is a change in temperature for dq, I reiterate, we shall use the formula ms delta t. Whenever there is a change of state for dq, we shall use the formula ml, and then we have to go according to the flow of the problem. That's it. Thank you for watching.